In this video, we're going to graph the function of these quadratic functions in standard form, and then we're going to describe the domain and the range of these functions. So we're going to begin with example A, f of x equals 3x squared minus 6x plus 5. Now we're going to need our axis of symmetry equation here to do this, and remember that that is x equals negative b over 2a. We're going to begin by first finding our a, b, and c values. We have an a value of 3, a b value of negative 6, and a c value of 5. From here, we want to find our axis of symmetry. So we'll plug our b into the b spot and our a into the a spot, giving us negative 6 divided by 2 times 3, which gives us a value of 1 when we plug that into our calculator. Now we're going to take that 1 and plug it into our equation so that we can find the y value of our vertex. So remember that we have an x value of 1. So when we plug it in, we get a value of 2. And so that's going to be the y value of our vertex. To finish graphing, we'll need one more point. So we'll want our y-intercept, which is our c value. And so our y-intercept is 0, 5. Now we're ready to graph. We'll begin by plotting our axis of symmetry at the point of 1. So this is what our graph is symmetrical over, what it reflects across. Then we'll plot our vertex at 1, 2. Then we'll plot our y-intercept at 0, 5. Now, because this is only one space away from our axis of symmetry, then that means on the other side of the axis of symmetry, just one space away, there exists another point on our equation. Now that we have 3 points, we are ready to graph. So we are now going to create our curve. Now we're ready to describe our domain and our range. Now our domain represents all of the x's that we're allowed to have. So our graph here, our function, is just going to keep growing and growing and growing as x gets bigger and bigger and bigger. And our function is going to keep growing if our x gets smaller and smaller and smaller. So what that tells us is that x can be all real numbers, which sometimes is referred to with this symbol, which is like a double-barred R. The domain of all quadratic functions is all real numbers. Let's talk about the range. So the range here is what y is allowed to be. So if we take a look at our function, we see that there is a minimum point that occurs at our vertex. So because we have a minimum and our graph is opening up, that tells us that our y value must be greater than or equal to the minimum value. And that minimum value is 2, which happens to be the y value of our vertex. So I want you to go ahead on letter B and write that down. F of x equals x squared minus 8x plus 7. And we're going to do this one together because it's a little bit different. So we'll begin by finding our a, b, and c, our axis of symmetry, and plugging our stuff in. So we're going to kind of do all of that in one great big swoop here. So we find that we have an axis of symmetry of 4. When we plug that in, we get a value of negative 9, giving us a vertex of 4, negative 9. Our y-intercept is 0, 7. Now we know that our domain is going to be all real numbers, and that our range is going to be y is greater than or equal to negative 9. Now I know it's going to be greater than because my a value here is positive, meaning my graph is going to open up, giving me a minimum, just like it did on letter A. But notice 0, 7 is not a point that exists on our graph. And we need to have 3 points in order to graph our function. So even though we have our axis of symmetry at 4, and that we can graph our vertex we're still missing some points. So we're going to pick one point to either the left or the right to plug in. So in this particular case, I'm going to go ahead and I'm going to plug in a positive 2, which is, even though it's a value to the left, it will still help us out, and it's a nice positive number. So let's go ahead and let's get a little bit more room to do this problem. So what I'm going to do is I'm going to take my equation, and instead of plugging in a 4 this time, now I'm going to plug in, I'm going to plug in this value of 2, because we want to see what does that give us. So I'm going to plug that into the calculator. I could have picked any number I wanted, but 2 seemed like a pretty easy number to plug in. So I'm going to take that, I'm going to plug that into my calculator, and when I plug that into my calculator, I'm going to end up getting a value of -5. Now that's a helpful value. So we have the point 2, -5. And so that is what I'm going to graph, is 2, -5. Now because I have that point, that allows me to graph a mirrored point on the other side. And now I have 3 points. And I'm able to graph my equation. So if your value doesn't fit on your graph, you can either remake your scale on your graph, or you can find a new set of points to use by simply plugging in numbers and plotting those points.